Hey guys, how's it going today? Today we'll learn about how to use the transfer learning technical in deep learning application. As you can see in this tutorial, I have a cat and a dog. Training data and validation data. And in there we have the Inception version 3 pre-trained model. And there is the Inception version 3 neural network architecture. It includes the convolutional, average bowling, max bowling, concast using pattern normalization, drag out fully connected layer, soft math layer. And now we just do radical. The first we import the Keras uh, application and we log in Inception version 3. We import Inception version 3 model, and first we log in the local weight files. Inception version 3 weight file reloading, and next we import the OS for do something, and from the TensorFlow.keras we import a layer, and from the TensorFlow.keras we loading we import the model, and now we load the pre-trained model. Using the Inception version 3, the API with the input strap is equal 150 and 3 channel. And the in low on top in on. And the weight is not. And now we log in the wave of the model using the log wave API, and we input the local wave file in, and now we summary the model. As you can see, this is the model of the Inception version 3. the input layer. Input layer is 15, 150, 150, and 3 channel. Convolutional, we use the Comcast the path normalization and connect it to the convolutional 2D. And activation function, convolutional 2D, mask bundling, convolutional 2D, deviation function, average bundling, mix 0. Mix 4, mix 5, mix 6, and mix 7. In this tutorial, I will raise the mix 7 layer from the mix 7 layer to there. I will freeze it and I will add a fully corrected layer and 6 more activation function for predict the cat and dog. As you can see, there the total parameter and training parameter is equal, and we have the non-trainable parameter. So now I will freeze the model by this. In the I will look for on layer in the pre-train model.layer, and I will disable trainable. I will disable on a thing, and after that I will summary again. So as you can see, the trainable parameter is 0, and all of things it cannot be trainable. So now I will guess the mix 7 by the last layer, and the last layer is equal pre-train model dot layer and get layer, and I will take the mix 7 layer, and we get the last output using the last the layer the last layer dot output. Okay, now I will use add some layer to continue training. First, I add the flatten the output layer uh, to one dimension, and first I will get the uh, I will add the flatten layer of the last output from the last output, and after that I will add a fully connected layer. Fully connected layer with 1024 15 units, and reload activate the variation function. We add the layer down, and now we add a dropout layer. We add a dropout layer rate, and in this tutorial I will drop out 20 100%, 20%. And the last, I will using the sigmoid layer for classification of the two class cat and dog. Final sigmoid layer for classification. Just layer then, and in there we have the two class, so we add one layer of the sigmoid. No, so now I will Now we'll summary the model. So as you can see from the mid 7 we had the flattened layer and the ends and drop out and we drop out 20%, and in there we add an advanced layer with a sigmoid activation function. So after that I will compile the model. In the combine model, in this model I will add the OMS. In there we use the OMS optimizer. OMS probability with the learning rate is equal. And the last function is the boundary cross entropy. Do the boundary cross entropy for calculate the loss and the matrix is accuracy. And now we summary the model. And there we have under the trend parameter E over the 38 million parameter. And in the next step I will process the data, pre-process data from the data sets. And in the previous video, I show you about how to using the uh, image generator for accommodation and how to uh, use the lot and output the label using the API of the TensorFlow, and in there use the strand folder and there we load the cat and dog filter, and in there use the trend and for accommodation data I will use the TensorFlow dot keras, and I use the pre-processing image, and I will import the image data generator. So the first I will add the trend folder, and I will assign for the generator with the rescale is equal. I will scale to 255. I will rescale the model to 255 in the floating, and I will rotate. Our rotation range is 40, and I will give the shift range 0.2, and the height shift range is 0.2, and the shear range is and the zoom range is 0.2. And now we have the horizontal flip. It means we have the horizontal in, and we have flip in horizontal dimension. And similar, we valid. We assign a valid folder for the image generator. Oh, so I'm sorry about the valid data. We not need to documentation for avoid overfitting, and for a lot of data to avoid overfitting in the trend folder, we just need to add some the augmentation technical and in the valid we not need to do it. And then now I will uh, I will flow the training image input of the training using the train data generator. Flow the training image input of the training using the train data generator. Maybe the train generator, and the train generator is for the so I'm sorry, but in there we have the train data chain, and we have the valid generator. Train that have the train generator is equal to train data chain to flow from the directory, and input there input we have the train folder input, and path size is word binary, and the class mode is the binary because we have the two class. And topic size we have the 150 size. And similar we have the valid generator using the valid data gen, and the folder is valid folder. So for more information about the class in the because we have the I'm so sorry about side train. Now I will bring the class index. After using the flow from directory, we just need to check the class index from the data using this feature. So now I will start training. Using the model data history. So sorry. print model fit function. And in the model fit function, the first I will fit the trend generator in there, and in the next we add the validation data in there, and we point to the valid generator data, and we add the step per equal is 100, and the equal using here is in digital I will 20 equal, and the validation step is 50, and the verbal 82. And after trend model, I will save model. Just wait for minutes, and when we waiting for the Model E training, I will write the predict. For predict function, I use the NP, and from the TensorFlow Keras preprocessing we import limit, and from we add the matplotlib and TensorFlow. And for import an image for testing, I using the tanker for import the file dialog for choose dialog, and for add a path of the file dialog, we using the API of the Tinker, and we ask to open the file name in there, and this API will return on the path. The next, I will load the save model using the TensorFlow Keras. TensorFlow Keras of the model, and using the load model function, and in there I will remove get and dot predict. processing. In the first, we have the image is in the Keras preprocessing image, and we're using the log image function, and we give the tag of the log image, and we set the target size for the target size of the model, and we have the S is for the image, and we want the image to array. We convert the image to array, and after that we divide from 255 for similar to the model, and in there I using the NumPy API for expand the dimension, and I will using the x-axis. And in the image, I will using the NumPy of the vector strength. So in the image, I will use in the image here, I will convert the image to the arrays, and I will expand the dimension and add the image to the vsec. The vsec is the sec array in the sequence vertically. And now I will predict using the safe model predict API of the TensorFlow, and I will input the image in there at a pass height. In there we can input the video for video detect, and if the class 0 is equal to 0.5, I will bring the image is dark, and if not, it is a cast. After that, I'm using the matplotlib for show the image. Just wait 4 minutes. In the waiting time, I will explain for you about the inception architecture. As you can see, there the neural network of the Inception Ocean Tree model, and from the mid 7 layer, I will proceed from the first to the mid 7 layer, and after that I add the flatten, and the dense and drop out layer and activation function layer, and I will train from the mid 7 to the end of my neural network. This is very useful of the transfer learning for save the time and save time and save the money of the training, because the incessant motion tree is a model with the very high accuracy, and to train to the very high accuracy will take a lot of time. So we use the transfer learning for reuse the model 5 of the exception person 3 for save the time. And as you can see, data from there is a high-end feature, and the output is classification, and the input, and the edge feature adjustment to design the neural network for get the feature instruction. I will show you in the next video in the future, and then the sharp instruction. There's a generator of the argument image accommodation for the training data, and the validation data now to validation. There will have the accuracy is were 90%, and then the validation accuracy, and the validation date and step per epoch is 100 for every epoch. We're using the 100 step with the training epoch, and the validation step is 50. The verbal is 2. Okay, successfully. For example, in there we show the cat picture and the model will run for this. Yes, okay. Okay, that's right. There is the image and there is the label. Okay, thank you for watching my video and welcome back.